Solving logarithmic equations. In this video, I'm going to do two different examples because they each play out a little bit differently than the other one, and I want to show you both ways. And then I'm going to have some practice problems for you to try afterwards. I put the steps that I'm going to take in red there in between the two problems. I'm going to do number 1 and number 2. So for logarithmic equations, if I was going to be presented with number 1, the first thing that tells me it's a logarithmic equation is the word log that exists in the problem. So I know I have to go about solving them like this. All right. So if I'm given number 1, log base 6 of negative 4x. That's a piece by itself. All right. That's one log. And then it's being subtracting log base 6 of 10. And then it equals log base 6 of 23. That's how you would read that. And the first step I'm going to take to solve this is to condense the logs, all right? And if you notice in an asterisk up there, the goal is to get rid of the logs in this process. Eventually there will be no more logs and it'll just be a linear equation, that type of thing, all right? So the first thing though is to turn all the logs on the left-hand side of the equation into 1. I'm going to condense it down into 1. I've made notes, if you remember from previous objectives, subtraction goes into division and addition turns into multiplication. In this case, it is subtraction. All right, that should jump out at you. I see that as subtraction between the two logs, and so I know that's going to turn into division. So that first step, I'm going to write 1 log base 6. All right, I need 1 log base 6, or log base whatever it is. And again, it was subtraction, now it turns into division, so I'm going to put a division bar. So, I need a numerator and a denominator now. The numerator is the first piece being held by a log base 6. In this case, this was the first log base 6, and this negative 4x is the piece that's being held by that log base 6. So that negative 4x goes on top. All right? Then I need a denominator, and the denominator comes from the second piece being held by the second log. This is the second log on the left-hand side of the equation. The piece being held by that log is right here, that 10. So whatever that exists there, sometimes it could be a 2x plus 3, it could be an x minus 4, whatever it is, that entire piece has to go in the denominator. Or if it was the first one listed, then it goes in the numerator. So I write 10 down there. And then it's going to equal still log base 6 of 23. I didn't touch the right-hand side. I don't have to condense anything on the right-hand side. Only condensing on the left-hand side. And I knew to do that because there was 2 logs on the left-hand side, so that tells me I have to bring them down into 1. Now, that's step 1. I am done. In this case, it was subtraction. If you notice, the next example I'm going to do is addition. The second step says if log exists on both sides of the equation, you cancel out the logs, all right? So in this case, if you notice, I condensed the left-hand side of the equation, and now I have a log base 6 on the left-hand side of the equal sign and a log base 6 on the right-hand side of the equal sign. And if this is ever the case, which you will be presented with this in your practice work, you can go ahead and cancel them out. Whatever exists on one side, if it's the same on one side as it is on the other, you can cancel them out. Technically, I would divide by log base 6 on one side, and then whatever is divided, the same on top and bottom, reduces down to 1, or you can just cancel them out. All right, so then that's step 2 for this one. I put step 3 down there as well, rewrite an exponential form if log and base equals a number. That's going to be an example 2. So to finish this off, step 4 says to solve remaining linear equations. So I have to write what remains. So this was step 2, the blue right there, and then what remains. Step 4, there's that bell. On the left-hand side, I cancel out the log base 6, so I just have a negative 4x over 10 equals 23. That log base 6 went away on the right-hand side too. Now I just solve it. And again, the solving part will look different, just depends on what type of equation you're given. But in this case, there's a 10 in the denominator, so I need to multiply both sides by 10 to get rid of that 10. Those 10s cancel out. I'm left with negative 4x equals 230. And then I divide by negative 4. Divide by negative 4. X is going to equal 230 divided by -4. And I'm going to leave it in simple fraction form, or simplest fraction form. So -115 over 2. And I am done. I have solved the logarithmic equation. First step condensing logs, then canceling out if they exist on both sides of the equation, and then just solving the remaining linear equation. Now, number 2 looks a little bit different. Number 2, we're going to incorporate this step, and number 2, if you notice, is addition, not subtraction. So for number 2, the same first step exists, though. I'm going to condense the logs, but in this case, it's addition. So addition turns into multiplication when I condense the logs. So if I'm going to do this step, I'm going to write log, and if you notice, there is no base with this log. It's just log something of 2. Whenever this case exists, you can assume that it's log base 10. All right? Whenever they don't write the base, you can assume it's log base 10. So in this case, it's log base 10 of 2 plus log base 10 of -3x equals 2. I just rewrote it, all right? So whenever there is no base here, you can just assume that it's 10. All right, now let's go ahead and condense. So I'm going to write one log base 10 for now. The first piece, this log base 10 of 2 is my first piece, correct? So it's holding, the log base 10 is holding that 2. So I'm going to write, it's holding this 2. I'll do it in purple. I'm going to write 2 there. And then the second piece is log base 10 is holding that -3x. That's the second piece that needs to be multiplied with the first piece because it's addition. All right? So, wait for it. I'm going to put parenthesis, whatever that second piece is. Again, sometimes that second piece will be a x minus 4. So then it would be 2 parenthesis x minus 4, and you'd have to do distribution. But in this case, it's just -3x. So I'll put -3x inside the parentheses. And then it still equals 2. I didn't have to do anything to that 2, so I just drop it down. There's no condensing that need to happen on the right side. All right, I'm done with step 1 for number 2. In this case, it was addition, so I had to multiply the pieces together. All right, now, step 2 in this list of steps we're not going to do for this one. Because if you notice, log base 10 of 2 times -3x equals 2. There isn't a log on both sides, so I can't cancel out logs. In this case, then, I have to call upon prior knowledge of rewriting in exponential form. So I'm going to jump to step 3 now. Step 3 states rewrite in exponential form if log and base equals a number. So in this case, the log base 10 of 2 times -3x equals a number of 2. So, if you remember how to rewrite in exponential form, I start with the base. So I'm going to put step 3 here. The base is 10. I'm going to draw my arrow to the power that exists on the other side of the equation, on the other side of the equal sign. So it's going to be 10 raised to the power of 2 equals whatever this entire thing is. Sometimes it'll be a division, so you'll equal the division piece. In this case, it's a multiplication, so it equals whatever that piece is. In this case, it's 2 times -3x. I'm done with step 3. I rewrote it in exponential form. Now I can move on to step 4, solve remaining linear equation. And if you notice, I said at the beginning of this video, the goal is to get rid of logs. In number 1, I got rid of logs in step 2 here. I canceled logs out on both sides. In number 2, I got rid of logs in step 3 here by rewriting it in exponential form. So I've accomplished that both times. Now, to solve this remaining equation, I have to do 10 squared is 100. And then equals, let's do this math now. 2 times -3x is -6x. And then I divide by -6, divide by -6. So x is going to equal the reduced fraction of 100 over -6, which is -50 over 3. And I am done. I have solved an equation that was a subtraction equation, and I solved one that was addition, and I also solved one where you can cancel out logs if they exist on both sides. and one where you have to rewrite it in exponential form. If you notice now, the practice work you have, numbers 3 and 4 here, and then 5 through 10 on this page, will incorporate both of those skills that I just showed you. Thank you for watching.